Welcome back. In our last video, we learned how to make decisions in our Java programs using if-else and switch statements. Now, let's learn how to automate repetitive tasks using loops. Loops allow us to execute a block of code multiple times, saving us from writing the same code over and over again. In this video, we will explore three main types of loops in Java: the while loop, the for loop, and the do-while loop, and understand when and how to use each one. So, let's return to our IDE and see how to work with loops in practice. As I mentioned earlier, loops are used to repeat certain blocks of code multiple times in a row. Today, we will explore three types of loops in Java: while loops, do-while loops, and for loops. We'll examine each one separately and, as usual, start with the first one, the while loop. This loop allows the code to be executed an unlimited number of times as long as a certain condition is met. Its syntax is as follows. We write the keyword while. Then, in parentheses, we specify the condition under which the loop should repeat. This condition, like in the case of conditional operators, must ultimately evaluate to either true or false. Therefore, without additional data for now, let's simply write true. Then we add curly braces, which denote the loop's block of code that will be executed multiple times. Let's write a message to the console here, saying, for example, this never ends. I'll write such a message here, this never ends, and it will never end because we've hard-coded the value true inside the parentheses. The loop will continue to run until the value inside the parentheses becomes false. In our case, it will never become false because we've set it to true. This loop is called an infinite loop. It will always run. And the message "this never ends" will be printed to the console an infinite number of times. Let's test this by running the application. We see that the message "this never ends" starts spamming. It will continue to run until the power on the planet runs out, our computer breaks, or we stop the application. Let's stop it and move on to the condition itself. As I mentioned earlier, inside the parentheses, we can place any condition that ultimately evaluates to true or false, which will determine whether the loop continues to run. For example, let's modify this loop slightly and introduce a variable called count. Set it to 1, and say that this loop will run as long as the value of count is less than 5. More precisely, the loop will continue to run as long as the condition is met. But if we run this program now, the loop will still be infinite because the value of the count variable never changes. It's always 1. Let's run it and see. Yes, the same thing happens. Let's stop it and make the variable change. For example, after printing the message to the console, we'll increment this variable by 1. We can do this by writing count plus 1. Or, as we know about the increment operator, simply count plus plus. Let's run the application again and see what's changed. We see that the application printed the string "this never ends" exactly 4 times. The message was printed only 4 times because at the end of each iteration of this loop, we increase our count variable by 1. That is, when the code reaches the while line, it checks the current value of count. Is it less than 5? Initially, it's 1. That means the condition is true. We enter the loop, print the message, and increment the variable to 2. The check happens again. That is, after the block of code inside the loop finishes, we return to the initial condition. Another check occurs. We check if the variable is still less than 5. At this point, after the first block of code has run, the variable is 2, which is still less than 5. So we print the message again and increment the variable once more. We do this one more time and one more time. Finally, after the 4th execution of this block of code, we increment the variable, making it 5. We check if 5 is less than 5. No, the condition fails, and the loop stops. The code execution then proceeds to the line following the loop. Let's write something like "it finally ended" here. Let's run it again to see how it works. We see that the message "this never ends" was printed 4 times, and then the message "it finally ended" was printed. That means after the condition failed, the code execution moved to the next line after the loop. Thus, this loop is no longer infinite. It runs exactly as many times as we specified. If we had set count to be less than 10, for example,
the code would have run exactly 9 times. In this way, we can define the behavior of our program to perform certain actions multiple times in a row. We've covered the while loop. Let's move on to the next one, the do-while loop. It is similar to the while loop, but with some differences. In words, the do-while loop allows us to execute a block of code at least once before the condition is checked. What does that mean? It means that in a while loop, we first check if the condition is true and then execute the block of code. In a do-while loop, we execute the block of code at least once, and then each subsequent iteration occurs only after checking the condition. The syntax is as follows. Let's write the same example but using a do-while loop. The syntax is as follows. We write the keyword do. Then, without any parentheses, we immediately open curly braces to denote the block of code that needs to be executed. We'll print exactly the same message. Let's also increase the value of this variable. After writing the do block, what do we need to do? After these curly braces, we must write the keyword while and specify the condition in parentheses. Let's copy the condition to make it the same. We'll place it here and add a semicolon at the end. The syntactic difference is that we write the keyword while with the condition at the very end, and the block of code to be executed comes before the while keyword. The only difference is that we don't write the do keyword before the block of code here. To ensure everything works correctly, let's comment out the while loop so it doesn't produce extra console output and set the variable to 1. Only to avoid too many messages in the console, let's change the condition to less than 5. Let's run the application again. We see that the message "this never ends" was printed exactly 4 times, just like with the while loop when the condition was less than 5. The only difference is that this block of code is executed at least once before the condition is checked. That means even if our variable was initially 10, meaning the condition would never be met, the block of code would still execute once. Let's run it and see that the condition doesn't match, but the message is still printed once in the console. If we had left the while loop in this form but set the variable to 10, the code would never execute, because first the condition is checked and then the action is performed. Here, it's the opposite. The action is performed first and then the condition is checked. If after the first iteration the condition is still met, the body of the loop will execute a second time. Then another check occurs, and so on, until the condition fails. Just like with conditional operators, if we have a Boolean value, for example, if we set isAllowed to true, since this value ultimately holds either true or false, we can use this value directly as the condition in the loop. Thus, the loop will run indefinitely until this value changes to false. That's about it. Let's move on to the next loop, the for loop. To demonstrate how the for loop works, I'll copy the example from our while loop, starting with the count variable up to this console output. I'll move all this a bit lower, below the do-while loop, and comment out the do-while loop. This way it will be easier to understand what's happening in the for loop by comparing it to the while loop. Let's uncomment it and review the key elements again. The first thing we have here is our count variable, which serves as our counter and is involved in the logic of running or stopping the loop. As long as the condition with this counter returns true, the loop will run. And at the end of each iteration of the loop, the value of this counter is increased by 1. In fact, such an example is the perfect case for using a for loop. That is, cases where we have a variable that essentially acts as a counter, increasing or decreasing with each iteration of the loop, are ideal scenarios for using a for loop. Alright, after the while loop has finished, I'll update the value of the count variable, set it back to 1, and we'll continue using the same count variable. Okay, the for loop. First, we'll look at the syntax, then the explanation as usual. The keyword for marks the beginning of our loop. Inside the parentheses, we're going to have a few things right away. The first thing is creating our counter, which will either go up or down. Or in our case, it already exists, so we're just setting a value for it. Although actually it's not really necessary here. I'll remove it. Next, separated by a semicolon, still within the parentheses, another semicolon, you write the condition for the loop to run. So just like with a while loop, there's a condition for it to run. I'll just copy it. I'll paste it in next, inside the parentheses, after count equals 1. And then, the third thing we put in here, in these same parentheses, as the third parameter, is how our counter will change, what happens to it at the end of each iteration. In our case, we're incrementing it by 1, so I'll copy that from there and put it here. Now, at the end of this third parameter, you don't need a semicolon. And after the parentheses, like always, we open up curly braces to define what work will happen inside our loop. Let's put some code in here to print a string. But this time, instead of "this never ends," we'll write, for example, "it ends soon." And at the end, like last time, let's print a string. Like we did last time, it finally ended. Let's run it first, make sure everything works, and then we'll go through it again and see how it all works. We can see that first. The string from our while loop printed 4 times, like it was before. And then the string from our for loop printed 4 times, which we wrote here. So essentially, fundamentally, the loops are completely identical. The only difference is the syntax of writing each of these loops. Inside the parentheses of a for loop, we need to specify 3 things right away. The first is creating or setting a value for our counter, which will either go up or down, or something will happen to it. We can also count backwards here, going negative, right? Like if our counter is 10 and we need to go to 1 and compare, for example, while our counter is greater than 1, we'll do something. On each iteration, we'll decrease it. So, basically, the first thing is creating or setting a value for our counter. The second is the condition for the loop to run. And the third is a modifier, basically changing our counter, what we'll do with it after each iteration. Like I said, you can create a counter here instead of using the current one. So let's leave the count variable for the while loop and let's make a new counter here. To make a new one from scratch, we need to declare it like a regular variable. In our case, it will be an int, an integer variable. And let's name it, usually it I, because it doesn't really carry any meaning other than just being a counter, so it has a corresponding name. And here again, we'll check I and modify I. Okay, let's make it 10 then. We'll run the loop as long as the I variable isn't down to 1. It will go down. Again, this I operation will happen at the end of each loop iteration. After this line runs the first time, our variable will change by 1. The condition for the loop will be checked, and then the second iteration will happen, and so on. Let's run it again, check that everything works okay. Yeah, we can see it ran a bunch of times. This should have run 9 times. 4 and 5, yeah, it ran 9 times. All correct. So a for loop is really for situations like when you know beforehand how many times you need to do an operation. For example, if you need to do something 5 times, we know it's exactly 5 and no more. Then we can create a counter, write conditions, write a modifier for the counter, and run it as many times as needed. With a while loop, we can write any condition here, complex ones, including with Boolean expressions. So, a while loop is more flexible in this sense, but a for loop is more convenient in syntax because we write everything on one line. Unlike a while loop where our 3 things, our counter, our conditions for the loop, and the modifier were written on 3 different lines. Here, we've combined it all into one line. Now I'll show you a more complex example using a for loop so you can understand what you can achieve with it. Let's comment all this out for now so it doesn't get in our way. And let's say that I want to print an analog of a multiplication table to the console. So I want to print something like this. For example, 1, 2, 3, 4, 5. Let's do a 5 by 5 multiplication table. Here we'll have 2, 3, 4, and 5. You get it, right? 5 in a row, 5 in a column. And here we'll have the result of the multiplication of the row by the column. For example, here 2 times 2 is 4. The next will be 6, 8. And here 3 times 2 is 6, 9, 12, 15. I probably need to add some spaces, maybe tabs or something. Anyway, I think you get the idea, right? Let's make a visual multiplication table like that. And these kind of things are very easy to do with a for loop, because we know exactly how many rows and how many columns we have, and we can do all this multiplication of these numbers to print them into the console in the body of our loop. So I'm going to write the code for a program that will print a table like this to the console, and then we'll break down how it works. First, I'll create one for loop, inside of which I'll create a variable for our rows. I'll call it row. I'll say that the initial value is going to be 1, the first row. Next, the conditions for running the loop. While row is not equal to 5, I'll write less than or equal to 5, and the modifier for the row. Every time we're going to print a new row, the current row number will increase by 1, so row plus plus. Next, I'll open the body of the loop. So the row variable will represent the number of our row that we're currently printing to the console. Then, within each of the rows, we also need to print a column. For this, Inside our loop, I'll make another loop that will create an int variable named, for example, col for column. The value will also be 1 because our column will also start with 1. The condition will be exactly the same, it'll go up to 5, and the modifier will be exactly the same, col plus plus. I'm opening the body of our inner loop again, and here, by the way, we can use the condition row less than or equal to 5 because we need to print it exactly 5 times, so I'm using less than or equal to so that 5 is included. Or if we wrote less than 6, then in that case, when our variable becomes equal to 6, the row variable, then the body of the loop wouldn't execute anymore. So I think it's clearer when we use the final digit, specifically 5, meaning it should be 5 inclusive, so I'm putting less than or equal to. And inside the inner loop, I'll write what value we need to print. So each value, each of the cells, is the result of multiplying the current column and the current row. So I'll just print the result of multiplying our row by the column to the console. And by the way, to add this kind of indentation, these 4 spaces, you can use this kind of notation. We'll add a special character to our current value that's printed to the console. A character written in double quotes, and with a backslash we write the T character. This indicates a tab, so after the value that we print to the console, we need to add a tab, those 4 spaces. It's backslash T, definitely in double quotes, and after the multiplication you need to write it with a plus sign. It won't add up mathematically since it's a string, right? It'll just get appended at the end. Okay, let's run it now, see if it all works correctly, and then we'll take a closer look at what's happening here. Let's print it. Okay, we can see that nothing works, everything printed in one column. That's because after I printed the value for a column and the entire inner loop finished, I didn't add a new line. Let's add a new line, just an empty system out print line. And here, we don't need to use print line, but we need to use just print, because each value in a row goes on the same line as the previous value, except, obviously, the first one. The first value is on a new line, that's what I added. But inside one line, each subsequent value is written on the same line. Let's run it again. Yeah, we can see a nice multiplication table is printed. It looks like everything checks out. 4 times 4 is 16. Yep, it all works. Let's go over how it works. And what is this syntax really? We can put any number of additional loops inside our loops, whether it's for, while, or do while. We can have a loop inside of a loop, and inside that, another loop. That's possible. Specifically, in our case, we're using one nested loop within our outer loop. How is all this working? How does the code execute line by line within this loop? When the code execution reaches line 40, our variable is created, which holds the row number, which is 1. And since the condition matches initially, we immediately get inside our loop body. In the next line, inside our loop, we see that a new loop is created. So, creating a new loop is going to happen multiple times within another loop. So, when we get inside our outer loop, we create a new loop where we create a variable to hold the column number. And again, because the condition matches initially, we get inside the inner loop. Here, when the code arrives the first time at line 42, the variable row is still equal to 1, because it's the first iteration of the outer loop. The variable col is also equal to 1, since it's the first iteration of the inner loop. And accordingly, in system out print, we pass 1 times 1, which is 1. Where's my output? Yeah, we see that 1 was printed. That's not row and not col, it's the product of the row and the column. So it's our 1 multiplied by 1, and the result is written here. Then we added a tab, that's 4 spaces, and after this line finishes, let me scroll down a little so you can see both. When our first value has printed, here it is, the 1 has printed, since we're still inside this loop, the code returns, or rather the variable, first of all, it's incremented by 1. The col variable, because we are still inside this little loop, the col variable is incremented by 1, and we return back to the beginning of our inner loop to line 41. The col variable is now equal to 2, and the condition still matches. 2 is still less than or equal to 5, so we move into line 42 again. Here we multiply our row variable, which is still 1 because we haven't gone back to line 40 for the second time. We are still looping between lines 41 and 43. The row variable is still 1, but col was just increased by 1. It's now 2. So 1 times 2 gives us 2. We print 2 and add another tab. And this happens 5 times, until the col variable becomes equal to 5. So let's just skip ahead 2 steps. It goes through that circle one more time. it goes through that circle again. And we've reached the point where the variable call is now equal to 5, right? So just now 4 was printed, and now our variable call is 5. The conditions match. 5 is less than or equal to 5. So we enter the body of this inner loop for the last time. We print our row, which is still 1, multiply it by 5, and we get 5. We add a tab character. It's here, you see, yeah. And then the variable call gets incremented by 1 and becomes equal to 6. 6 doesn't match the condition anymore. 6 is now greater than 5. So this inner loop stops running. What happens next? Since this loop has stopped running, the code continues execution from where the inner loop finished, which means it goes to line 44. A blank system out print line is called without any parameters. So we just print a new line. We printed a new line, and basically, in the program, we are now at line number 2. This time, because it is, let me scroll down a bit more, because it is the last line of our outer loop, there's nothing after that, just the end of the outer loop. So the variable row gets incremented by 1 here. The variable row becomes equal to 2, and we go back to line 40, where the condition check happens again. 2 is still less than 5, so we go inside the loop again. And inside the loop, we see that we need to create a new loop again. So this action of creating a new inner counter call happens again. So the variable call gets created again and is equal to 1 again, while row is equal to 2 now. Call is equal to 1, so the condition starts to match. We enter the small loop again and start looping inside that little loop 5 times again. So the first time we multiply row, which is now 2, by call, which is 1, and we get 2. Here it is. 2 has been printed on the second row because it's only the second time we are executing the outer loop, but the sixth time we are executing the inner loop. We have completed the first 5 times of the inner loop and are running it the sixth time, but since we have gone back to line 41, then our counter is reset. Well, not really reset, but it's a whole new variable that was created. And so, we printed our value again 5 times, looped in this inner loop 5 times, reached the new line, printed a new line, incremented the row variable by 1, it's now 3, 3 is still less than 5. Again, we create a new loop with a new variable call, which equals 1, and now for the third row, we are printing 3 times 1, 3 times 2, 3 times 3, and so on. And in this way, our 5 rows are printed. During the printing of the last row, when we finished printing, our row was 5, we created this inner loop for the 5th time, and the variable call is also equal to 5. We printed 25, went to this line, printed a new line, and then the row variable at the end of this outer loop was incremented by 1, became 6. So the condition no longer matches, and we don't get inside the outer loop. So the inner loop won't get called anymore either. We don't enter this loop. This means the code transfers execution to the end of our loop. So it's the next line. We don't have a next line. Well, let's add something like end of loops. And let's print it one more time and see that at the very end, after all of our multiplication table, our message was printed. As long as all these conditions were matching, the code execution was jumping between lines 40, 41, 42, 43, 44, and it looped like that 25 times in a row until it had calculated all the values. To demonstrate more clearly how it all prints, we can try to add something like this. This won't be very clear right now, but just to make our table print more visually, let's add this using capital thread, dot, sleep, and inside we'll put 1000, which will mean that at this point, when we have printed another value, we will stop for 1 second and just wait, doing nothing. And only after 1 second has passed will we continue our execution of the entire code. Here, to make this all work, you need to add an exception. You can just hover your mouse over that word and click this text. Add exception to method signature. We'll go through exceptions later, so just ignore it for now. If you don't have that pop-up, then at the very end of our main method declaration, here, at the end, you need to add this text before the curly brace, throws interrupted exception. Again, don't worry about what it is, we will go through this in the following videos. But for now, let's just run it and watch how it's going to work. Look, now we can see one by one what's happening, right? So we print the first row, then we print the second row, and so on, calculating each value one after the other. So while the data is being printed within the same row, that means we're inside our little loop, inside the inner loop. Once we go to a new row, that means that we've moved to the outer loop a second or third time. I think this visual example was more clear. But in any case, if anything is unclear, try playing around with it. Put these pauses in different places. Try making the pauses longer. If you want 3 seconds, then put 3000. Basically, play with it and watch it yourselves.
Fantastic! You've now learned about the three fundamental loop types in Java: while, for, and do while. Understanding how to use loops effectively is crucial for writing efficient and powerful programs that can automate repetitive tasks. Keep in mind the key difference between the loops and when to choose each one. Pay attention to the loop conditions to avoid infinite loops. For homework, read about break and continue keywords that are sometimes used in loops to control the execution. In the next video, we will explore ways to create our own custom methods. Remember, you don't learn programming when you are not coding, so practice writing different types of loops and experiment with various conditions and scenarios. If you have any questions, please leave a comment below. Don't forget to like this video and subscribe for more Java programming lessons. See you in the next one, and happy coding!